All right, so now we're up to the last step of this problem, which is to write out our general solution. And again, we were solving a 2 by 2 linear system. And again, we need to have two linearly independent vectors to solve this 2 by 2 system. And again, we have our two vectors here in our problem. So again, every single 2 by 2 problem requires us to have two arbitrary constants. So we're going to have a C1 times the e to the negative t sine of 3t, e to the negative t cosine of 3t, and then another arbitrary constant, C2, times the other solution vector, negative e to the negative t cosine of 3t, e to the negative t sine of 3t. And again, we can prove, if we wanted to, that these two vectors are linearly independent by finding the Wronskian, and we could prove that they're a solution by just placing them back into the original differential equation. But again, it's important to keep in mind here that because we have these two constants and because of the trig identities that are out there, there's a lot of different ways to express these final answers. So if you do look at a solutions manual or an online resource, you will sometimes have a correct solution, but it just will not appear to be the same solution that's given in the problem. So it's very important to make sure that you do understand that there's a lot of variation in the appearance of correct answers. But again, this is our solution to that 2 by 2 linear system with a complex eigenvalue.